All right. So, welcome to Command Institute. So today we'll be looking at Raft Foundation. So before we begin to use the software to actually model and design the particular type of Raft Foundation, we actually need to understand what the Raft Foundation is and the working principle of that Raft, so that when we start modeling, we can be able to feel what we are designing, can be able to understand what we are designing. So we don't just model. All right. So, like I said, we're looking at the Raft Foundation. So we now want to understand what Raft Foundation is. What is Raft Foundation? From what is written here, you can see that uh, Raft Foundation is actually a thick concrete slab. That is one major uh, part of the Raft Foundation. The thick concrete slab resting on an area of what? Large area of soil, reinforced with concrete, supporting columns and walls, transfer load to the structure, the load of the structure to the soil. Said the usually mass foundation is spread over the entire area of the structure it is supporting. So as you can see from this picture, this is a type of foundation we call the slab beam wrapped slab. This is a upstand with the upstand beam. So from the definition, we can see that the first thing they called is thick concrete slab. This is the thick concrete slab, and they go on to say it is resting on a large area of what? Soil. So just like when you have your footing is resting. Let's say you have a footing of 2 meter by 2 meter. You see that that footing covers that particular area for a particular column. The footing is directly or resting on the soil of that particular area. So, but when you have a raft, so instead of the footing to be covering one particular area for the column, it is now covering for every column in the entire structure. It is covering the whole building area. So that's just the major difference between that raft and the footing. The footing is for a particular column, while the raft is for the whole column. So and that is why he said it's a concrete slab, just like your footing, which is a concrete slab, resting on a large area of what? Of soil. So as you can see. So one thing you can take out from here, for any of these foundations to be wrapped, there must be a concrete slab. And there's once there's a concrete slab, it must be a very large area of concrete slab resting on the soil. And eventually must be supporting columns or walls. Alright. So it now basically means that okay, since it's basically used where we have a very weak soil, you understand? That the individual footings for each column will not work. So you need to cover more area of what? Slab. So you cannot look at it this way. Um, let's say for one column, you have let's say you have 20 number of students. So for let's say you have about 10 columns. Yeah, you have 20 students, you have 10 columns. So on a light, on a good situation, if we said two students to carry uh, one column, two students to carry one column. So you share them in that manner. So, but now due to the how heavy that structure is, if two students will carry one column, it will be too heavy on them. Like two students handling one column, it will be too heavy for them to carry. But you see that the stress will be reduced. Okay, when you now say, okay, the whole student should carry the structure at the same time. You find something like a plywood, just to cover the whole area, and ask the student to, distribute yourself and carry the structure at the same time. You see that the amount of stress each student will feel will be lesser when they are now carrying it individually. So that's just the main principle. That's the difference between the footing and the raft. So the footing is two students carrying it individually, and the raft is now when all of them are now carrying it at the same time. There will be less stress on the soil. So covering more areas of the soil means we are bringing the much soils to carry the structure at the same time, thereby reducing the stress on the soil. But when you do the footing, it will be some little amount of soil carrying a particular column. So that way the stress will be much at that area. So that's just the principle of what raft foundation is. And like I said, you use for residential, commercial, where the soil condition is poor. And you also use for storage tanks. So you see that for storage tanks, silos, it's a must that you must use rafts, whether the soil is good or not. For the storage tanks and silos, you use raft foundation. All right. So now we'll now move on for why do we need raft foundation? So and the first one says whenever your building loads are so heavy or the level pressure on soil is so small that individual footings will cover more than the floor areas. So just like what I've said, it's basically when the soil is bad and individual footings becomes impossible. So you see, in the sense that for one column we might be needing 5,000 by 5,000 what size of what footing. You go to another column using 5,000 by 5,000. You see that all of them will start to clash. They will begin to overlap. So it's now better you use the route foundation. Another one is when the soil, that is the part B, when the soil is sufficiently erratic and it is difficult to define and assess the extent of each of the weak pockets or cavities and thus estimate the overall and facial settlement. So what he's saying is what you mean by erratic is when something suddenly changes. That is the properties of the soil is not closely uniform because the soil can never be uniform, but there is a difference in changes in the soil property. Okay, so you cannot actually determine, okay, the estimate the settlement, the artificial settlement. You couldn't get the property, you couldn't just define the soil because there is erratic change in the properties of the soil around the site. So in that case, raft foundation is now what recommended. And the third one, C, says when the structures and equipment to be selected are very sensitive to differential settlement. So like just your storage tanks and silos, so that those ones are very, very, they are very, very, very sensitive to differential settlement. So that foundation is what recommended. And again, the D now says where structures naturally themselves you need the use of what raft foundations, and you are giving such silos, chimneys, and water towers. These ones are just natural. Whether your soil is good or bad, you just need to use that raft foundation for it. So you also need where you need your basement. Okay, and also the last one says buildings where individual foundation, if better, will be subject to large bearing bending moments. It may result in differential rotation and differential settlement. So it's still the same thing we are saying. So that is it. Now, what are the types of foundation? So the first one is the flat slab raft foundation. So as you can see from the picture, okay, let me read what it has. It said flat slab rafts, which are flat concrete slabs having a uniform thickness throughout. This is most stable where the column loads are moderate and the column spacing fairly small and uniform. So as you can see, we have this, the slab is resting directly on the what, on the soil. Then we begin to place your columns, and also you can see that it has the same what thickness throughout. Okay, so it is uniform where the loads are very what, moderate, that is small, and they are uniform. Okay, just like when you have 60 kilonewton, you have 100, something about 200 or 500. So, but this is usually you have something like, let's say, you have 500, you have 600, 700, 500. They are just moderate, they are uniform. Okay, so this is where you are used. So one of the problems of this type of raft foundation is that you have to design against pointing shear, just like you design against pointing shear in your footing. For this one as well, you have to design for it because this column are coming on it, and once they are coming on it, there is high possibility of what, pointing. So because of the pointing shear, this will now warrant an increase in the thickness of what, the slab. So if your column load is very high or big column loads, you see that you might now require what, more thickness of slab. So in that case, making it more costly. Alright. So another type of raft foundation is the slab to beam raft foundation, right? So, and this type of foundation can be upstand and the downstand beam. So this is the upstand beam where you have the slab first, then you have your beam coming out after the slab, then your column. So this is mainly used where the the column load is high, you needed more stiffness and rigidity, such that when the slab raft, yeah, foundation is required more thickness. Okay, you want to make it less costly, let it be economical. You can now introduce beams along the column lines so that you can reduce or stop the pointing shear. Because with the flat slab, when the column loads are heavy, you have to increase the thickness of the slab to control the pointing shear. But that problem is now solved by having a lesser thickness of slab and at the same time eliminating pointing shear, because once you introduce beam, the pointing shear will no longer what, happen. It will be taken care by the beam. So once you have taken care of the pointing shear, you no longer need to what, increase the thickness of the slab anymore, because what the slab will now serve is to withstand the earth pressure. It's no longer to withstand earth pressure and what, the pointing shear. So once you introduce your beam, it will now eliminate the pointing shear. Thereby we are making this more economical than the flat slab. Okay, so as I said, this can be upstand or downstand. This is upstand where you have the slab first and the beam. But in the downstand, you have the beam first before the slab. So this is the type of foundation. So let's read what they have there. They said slab and beam raft is used as a foundation for heavy structures where stiffness is the principal requirement to avoid excessive distortion of the superstructure as a result of what, vibration in load distribution over the raft or the cost. So it's still the same thing I've said. So that is just the major thing there. It's more economical, especially when there is heavy load, because what will cause ordinary slab to increase thickness is the pointing shear, but the beam has actually removed that. So that is this. Then Another type of raft foundation is the cellular raft foundation. Okay, so let's see what they have. They said when the foundation is constructed for very heavy loads and on loose soil, or where the soil tends for unevenness or uneven settlement. In such case, the thickness of the raft may exceed 1 meter. In such case, cellular raft is more preferable than ordinary raft foundation. This type of foundation consists of two slabs where a beam is constructed of two slabs in both directions, forming hollow cellular raft foundations. So what he's saying is, as you can see from the diagram, when you have a heavy load, okay, so instead of constructing this in like what they said over here is exceeding 1 meter. So instead of having a slab of thickness about 1 meter, just imagine you casting slab for up to 1 meter. That would be way too expensive, right? So you can actually use this type of what foundation system for such. So in that case, you are creating a void. Instead of filling it up with concrete, you can have something like this and they still perform the same function. Alright. So that is what the where the cellular raft foundation what comes in. Now for our course, this is the type of foundation we design. Okay, so we're going to use the downstand beam raft foundation. And for us to continue to design, we need to understand what the working principle of this downstand beam. Alright, as you can see from the diagram, this is a downstand beam. As I told you, the upstand we have the slab first, then we have the beams. But in the downstand we have the beam, as you can see, before we cannot have what the slab. And over it we have a compacted earth fields. What do you mean by earth fields is now when you have to, when you're constructing your normal buildings, after you have come up above ground, natural ground level, you have to backfill, you have to fill in before you can now do your oversight concrete, right? So the same thing is what happens. That's what we call the fields. Okay. So now, like I've explained, or that is also what is written here. That's what I've written here. Maybe in your own time you can read this. So the principle of this is that because of the pointing shell, like I've said before, which now makes the slab to be more thick. So in order to reduce or to eliminate the pointing shell and to reduce the thickness of the slab, when you introduce a beam along the column lines, it will now eliminate the pointing shell, then require what? It will now require less thickness of slab. Okay, so and that is what is saying here. That is what is saying here. Okay, so now how this is constructed on site is after you excavate along the column lines, you put your beams. After you have put a beam, you begin to backfill. Especially the recommended backfill is the granular types like your sand, gravel, and make sure it's what compacted so that when it's compacted, the load from the superstructure on the slab, because after you have compacted it, you now put your raft slab. So when the load from the superstructure, that is from your ground floor, yes, from your ground floor, when the load comes on the slab, it will now cause the earth fields. You already backfilled with the material. It will now cause the earth fields to react with that what we call the earth pressure to counter back. When there's a load, this tends to the slab tends to bend inward, but because of the backfill, there's an earth pressure that will react back. And once it reacts back, As you can see, the reaction forces. So once that happens, by these reactions, this one bending downward and there's a reaction upward, the load on this now from this slab will now be transferred to this beam. As you can see this red arrow. So it's now the load from this slab, but this beam is supporting, these two beams is supporting this particular slab. So in that case, it is now believed that both of them will collect the same amount of what? Force coming from the slab. So by this reacting upward and the slab coming down, this reaction will now cause this slab to distribute the load to these beams. Okay? Yes. And because of this upward pressure, the wrap slab will no longer act like the suspended slab that we know. In your solid suspended slab, the bending moment is always downward this way. The bending moment is always downward. But when you have now a wrap slab, because of the excess pressure, your bending moment will now be what? Upwards. That is means the upper part of the slab will now be what? In tension. But in a suspended slab, the downward now becomes in tension. I don't know if you can see the principle here now. So at this, the midpoint for your suspended slab, the down part will be in tension, but for the raft, the middle part at the span will now be what? In tension. So because of what? The upward pressure. So because of this now, your reinforcement will be at the top. Then when you come to the beam part, the tension part will be at the what? Bottom. So you're going to place your for your beam, your reinforcement will now be at the bottom. That is when you are detailing for your slab. Remember, you have to when you detail your support in a suspended slab. After you have detailed the bottom bars, you come to the support to detail your top bars. All right. So that top bars on the beam over the beam area, we call it your top bars. So, but when it comes to this case now, it becomes the bottom bar. It's no longer the top at that point, and the bottom bars here now becomes the top at this point. So that is the principle. I'm still going to send you guys a video that actually should. Let me see if I can bring that in. Let me see if I have a picture of what I'm trying to say. Um, okay, like I don't have it. Let me use this one. So, all right. So as you can see, this for the suspended one. You see that here is in tension, and the at the support side is also in tension. So if you are detailing this place, you're going to detail it at the top, and here your bar is going to be at the bottom. But for the raft, this is going to be opposite. I think I should have this raft. Let me see. Off stand, line point. No. Okay, let me go to download. Let me see if I have it. Okay, like I don't have it. So the opposite is now the case. This one now comes up here. So instead of going this way, it will now go this way. So I would just recommend you search for the bending moment of a raft foundation and be able to understand what I'm saying. Okay, so that is how it works. And also when you read this thing, that is also what it's saying. Alright, so in that case, how we are going to model that is that when we come to our plotter, we have to model the beam. You model the beams, then you place your slab at the foundation. So the software will automatically understand that what we are trying to model is a downstand raft. Now, one important thing is about this is that is not when it's being constructed, you must make sure that they follow the due process. In the sense that if they go on site and they construct another thing, you will now have a failure of that foundation because an assumption has been made in the design. So this, like you can see in this picture now, like I said, you have to construct the beams first. This is the beam. As you can see that here is very open. So after you have done this now, you can now bring in what? Imported fills, which is like sand. You begin to fill in layers and compact, just as you can see that they have filled up to this level, and make sure you have what? Compacted. Now, why you have to compact very well and make sure that it's a granular material is because over time, if you don't compact it very well, the material will now what? Settle. And once it settles, you know that there will be a gap under this slab. So once it settles, instead of this soil to be in direct contact with the slab, it will now come down a bit. You know when something settles. So here will now becomes a void. And once it becomes a void, this raft slab will no longer act as a raft slab. It will now act as a suspended slab because there is no longer a net fill under it. So and once this start acting as a suspended slab, the design assumption has been what? Compromised. In that way, it will make the structure what? To fail. So that means the construction must be well supervised and monitored. Because once you don't fill the material well, the material or the design assumption of what has been compromised. Okay, so that's why you must compact well. You must use a granular material. It's not even a must, but make sure you compact well. You can even use in a waterlogged area. Sand is recommended because it doesn't retain water. But where in area where there is not waterlogged, just like in any state, for example, you can use your other types of soil, but make sure you compact it very well so that you won't have to settle. But once it settles, the foundation will start failing. Okay, so then why we normally prefer this down stand over the up stand? Because okay, now the challenge of the down stand beam is because of that settlement where the soil will settle and leaving the under the slab will be void. And once the under the slab becomes void, the foundation fails. Okay, so people begin to doubt the reliability of what? The downstand beam. So they say, okay, the upstand beam is more better because in this case now, the slab is coming directly with the soil, with the natural soil instant. So there is no way there will be a void under the slab. But in this case now, you see that it's constructed over natural ground level. So you have to backfill. But in downstand, the slab is directly coming in contact with the natural soil. So there's nothing like kind of a settlement of a thing. So people said, or professional says, is more reliable. Like what I've explained now, you see that it's more reliable. Okay. But at the same time, it's more costly compared to the downstand. Because once we go like this, when we come to the ground floor, we still need to do what we call the, you know, the oversight concrete again, which is now you do slab first, come again, oversight concrete again, like this now. So you do the wrap slab, oversight concrete. Then here you backfill it. Once you backfill, you now do your oversight concrete. So people say, okay, it's what? Costly, like we have said, it's costly as we have said, which is true. So, but now with the downstand beam, we don't need to do two slabs. You just put your beam, construct up to the ground floor, and use the raft to form your ground floor as well. So that is one good thing of the downstand over the raft beam. Okay, so hope we understood up to this level. So in case of any questions, you can reach out to me. So the main thing here is that we have known the different types of what Raft foundation, what Raft foundation is, and the one we will be designing in our course. So we know the working principle. We're just going to model our beam, then model our slab, then we design. All right.